Alrighty then, folks, here we are. We're going to complete this section with example number 7, examining a polynomial model. So the table below shows transactions in millions by users of bank debit cards for selected years. And as we can see there, they have been increasing, well, at least from 95 to 2011. Okay, so let's look at the first part of the problem here. So using x equals 0 to represent 1995 and x equals 3 to represent 1998, and so on, use the regression feature of a calculator to determine the quadratic function that best fits the data. Give coefficients to 4 significant digits, plot the data and the graph. So what we want to do right now is we want to use, and it's going to be done on the graphing utility or using Desmos, which I'll use again. That's the only way that you can do this kind of problem here. So basically, we want to use the data there, and we want to put it to a quadratic regression and see how closely aligned is that. I mean, is this growing at a quadratic model? And then our next set is going to be try it using a cubic model, try it using a power 4 model, and then see which one is bestly represents this data. All right, so first thing is that you're going to need to make a table, and they kind of helped us here by saying that our x value is going to start off to be 0, right? Oops. It's going to have us make this to be 0, and then they said make this one 3, right? So let x equals 0 is 1995, and x equals 3 is 1998, and obviously it's 95 plus 3 is 98. So then what would 2000 be? Well, that would be 5 then, right? Because from 95 to 2000 is only 5 away, and so forth. So then this must be 9. From 95 to 2004 is 9 spaces away, and then 13, and then 16. So these right here are going to be our x values, and then this right here is going to be our y values. And so what we actually need to do is actually plot these right now in our graphing utility. And once again, I'm going to be using Desmos to do that. Okay. So if you want to do this, you're going to go to the edit. Actually, you're going to go to the left side where it has a little plus symbol and it has table right there. Okay. So I'm going to first put in all my x values. So it's 0, 3, 5, 9, 13, and 16. And we can put in our other values now. So we have 8, 29, 37, 65, 52, 90, 14, 10, 6, 28, 46, 4, and we had 39, 0, 4, 9. Great. So what we do now is we're going to want to go ahead and do our regression now. And the way that you do that is it's going to get a little tricky here. So you're really going to want to, you may have to pause it here or there, but you're going to want to do Y and then press the number 1 key, and it's going to make a sub 1. And this is going to tell the computer right now that we're going to do a regression. And then you're going to want to do the tilde symbol. Tilde is to the left of the number 1 key. So do the shift button and then tilde. Okay. And so since we're going to do a quadratic, okay, let's just go back right here. The quadratic form looks like this: a1 x squared x sub 1 plus b1 x sub 1 plus c1. I know this is super complicated right here, but I'm not going to go through explaining what are all of these little ones, but just this is, we need to put this in, and Desmos will kind of take it and it's going to kind of put it in there. Okay, so that's what I'm doing right now. All right, so then we'll do a1, and so as you can see down here, it's going to start doing all this weird stuff because it's doing our regression. So, and when you do this part, you have to do the power first, and then you do the 1. Okay, just like that. Plus b1, and then x to the power, oh, there's no power there, there, and then plus c, and then c1. Okay, so there's that there. But we don't see it right now, right? Like it's like, like, okay, like where is it? And this is looking really weird, right? You're like, what is that right there? So if you go to the right side under the tools, you can change the x values, right? So I might want to go from like -1 to like 14. And I don't know, let's see, how far should I go down? Maybe -10,000, I don't know. Or maybe -1,000 to 40,000 or something like that. Let me just see how that looks. Okay, well that looks a lot better. So basically, you just need to kind of change the parameters. And basically, I just looked right here and said, okay, these are my x values. So I know I want to go from like 0 to 16, right? And then I want to go from like, I don't know, negative or even like 0 to 40,000. So that's how I know what to do right here. I didn't like randomly choose those and like knew some secret thing. It's just I'm just using my values there. So now we can kind of see it. We're like, oh, okay, well that looks kind of good right there. You say, okay, well, what the heck is this? Well, I'm not going to go into the great details of all this, but basically what we need to know for our problem is what is our A1, our B1, and our C1? Well, that's this right here, 127.655. Our B1 is 377.34, and our C1 is 868.67. So this would be our answer then right here. And so maybe if I just kind of took a picture of that guy right there, and let's go back here. Okay, so let's just let me just put that in here. Desktop. There we go. Okay. So the answer then for part A, and I won't do this for part B and C because you'll kind of catch on right now. But basically, the answer for part A is you would say y equals to our coefficient of A, so 127.655x squared. And then our B is right here, 377.334x. And then our C, 868.671. It's pretty hairy, huh? Yeah, that's the way it's supposed to be, and that's why we don't calculate this by hand. So this is our answer for part A. And just go ahead and jot down this number right here because we're going to use this in part D. So we're just going to say it's our squared value is 0.9978. Okay, so that's the answer for part A. Great, so now when we look at what does part B ask us to do now, we're doing the same thing in part A, but now do it for a cubic function. So basically we're just going to add, it's going to look like this now, y sub 1 tilde a sub 1 x cubed, right, plus b sub 1 x sub 1 squared plus c sub 1 x sub 1 x, and then plus d sub 1. So see the pattern there? It's always a, b, c, d. They always have ones there, but it's x cubed, x squared, x to the power of 1, and so forth. So we're going to do the exact same thing, and now I'm going to plug this in now. Okay? So if you haven't already seen this now, this is kind of a long problem here. Great, so I'm just going to go down here, and I can get rid of this by, you can't see it on my screen because I'm only showing part of my screen, but to the left of this is a little colorful ball. Just kind of click on that, and then it goes away there. See? And then you can do the same thing with this. You just click on this, it just goes away. But then you don't lose all this stuff. All right, so let's go ahead and do this now. So y sub 1 tilde, and here we go. So a sub 1 x to the power of 3, 1 there, plus b sub 1 x to the power of 2 sub 1 plus c sub 1 x sub 1 plus d sub 1. Great, so check that out. That's pretty cool. So kind of took our points and see like how is it fitting in a cubic function there. And again, like what you would do now is you would copy down the value of A, B, and C, and that would be, and D. Those would be all of your coefficients right here. And then we're going to write this number down right here as well. So I'm just going to screenshot that so that we can kind of compare that. Okay. So I'm just going to kind of move down right here. And let me just paste that inside there. Great. Kind of shrink that a little bit. All right, so there's our cubic right there. We have our quadratic up there. Let's look at part C now. It said repeat part A again for a quadratic now with the degree 4. And yeah, so now we're going to do this exact same thing, but now we're going to go to the power of 4. 3, 2, 1. And yes, this problem just got a lot longer. All right, great. So I'm going to turn that off again there. And let's do it. Y sub 1. And then tilde. A sub 1, x to the power of 4. Sub 1 plus b sub 1, x to the power of 3. C sub 1, x to the power of 2. D sub 1, x sub 1, plus e sub 1. Great, and we got this gnarly looking thing over here. Great, and this is what we wanted, was our A, B, C, D, and E, and this is our R2 value right there. I'm going to copy that as well again. Great, and let me just copy that down here. Okay. So we have all those guys there, and the last part now, part E, it says the correlation coefficient, R, is the measure of the strength of the relationship between two variables. The values of R and R squared are used to determine how well a regression model fits a set of data. The closer the value of R squared is to 1, the better the fit. Meaning, a better fit meaning that that's the way that that data is being modeled by that type of function, okay? So compare all of the R squares for the 3 functions in part A through C to decide which function best fits. And so that's why I did the copy and paste. So the first one was 0.9978. The second one was 0.9982. And the third one was 0.9999. So obviously the third one wins, the quadratic with the power 4 wins. And so that one fits very, very nicely. It's almost 1 in itself right there, which means it's being modeled more by a quadratic to the power 4.